In supply and demand problems, Y is the number of items the supplier will produce or the consumers will buy if the price of the item is X dollars. Where our supply equation is Y equals 6x plus 530, and our demand equation is Y equals negative 8x plus 740. We first want to find the intersection point of the two lines, then determine what the selling price is when the supply and demand are in equilibrium, and then finally we want to find the amount of items in the market when the supply and demand are in equilibrium. Let's begin by looking at the graph of these two linear equations on the coordinate plane. Notice the supply equation is graphed here in red, and notice how because the slope is positive, we have an increasing linear function, which means as the price increases, Y, the number of items supplied to the market, also increases. And then the demand equation is graphed here in blue. Because it has a negative slope, we have a decreasing linear function, which means as the price increases or as X increases, the number of items consumer will buy will decrease. The equilibrium point is when the supply and demand equations are equal, which would be at this point of intersection. And our first question was to find this point of intersection, so we'll do this algebraically by solving this as a system of equations. So let's begin by doing that. If we want to solve this as a system, the preferred method would probably be to use substitution, where if Y equals 6x plus 530, we can substitute 6x plus 530 for Y in the second equation. By doing this, we'll have one equation with one variable, and then we can solve for x. So if we make this substitution, we would have 6x plus 530 equals negative 8x plus 740. So for the first step, we want the variable terms on one side of the equation. Let's go ahead and add 8x to both sides. So this would be 0. So now we have 14x plus 530 equals 740. And now we'll isolate the variable term by subtracting 530 on both sides. So we have 14x equals, this would be 210. And now we divide both sides by 14. So we have x equals 15. Which means for the point of intersection, we now know the x-coordinate is 15. So to find the y-coordinate, we'll substitute 15 for x in either of the original equations. So if we use the first equation, again we now know that x equals 15, which means y must equal 6 times 15 plus 530. Well, 6 times 15 would be 90, so we have y equals 90 plus 530, or y equals 620. Now if we use a second equation, we would still get y equals 620. And again, this would be the y-coordinate of the point of intersection. Let's go back to the graph to verify this. Notice how the x-coordinate of the point of intersection is 15, and the y-coordinate of the point of intersection is 620. So going back to our three questions, we just found the point of intersection to be 15, 620. Next, what is the selling price when the supply and demand are in equilibrium? That would be the x-coordinate of the point of intersection, so the selling price is $15 when the supply and demand are in equilibrium. And then for the last question, what is the amount of items in the market when the supply and demand are in equilibrium? That would be the y-coordinate of the point of intersection, which is 620. So the number of items is 620, again, when the supply and demand are in equilibrium. I hope you found this helpful.